Hey, it's Mitchell. Welcome to another video in the RSP Education series. Have you ever wondered how massive factories, treatment plants, or high-tech labs always seem to know exactly what's happening at all times? From monitoring pressure in oil pipelines to keeping pH levels just right in water treatment to controlling temperature in pharmaceutical production, it all comes down to one thing, and that's sensors. These tiny devices are fundamental to automation. They're the reason processes run smoothly, safely, and efficiently 24/7. But not all sensors are created equal. Each one works differently, each one solves a specific different problem, and knowing how they work, that's what turns a good engineer into a great one. In this video, we're diving into the core sensor types used in industrial automation and exactly how each one works. By the end, you'll not only understand the tech, but you'll also be able to apply it with confidence in the real world. If you like this content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. Let's start with the basics. What are sensors? They're devices that detect physical or chemical changes, and they then convert those changes into measurable signals. The reason they're important is because they're critical for process control, safety, and efficiency, especially in industries like oil and gas, pharmaceuticals, food and beverage, water treatment. Some of the core sensor types and how they work: temperature sensors for one. Its purpose is to measure heat energy in a process. Let's break down the three main types. RTDs, that stands for resistance temperature detectors, and the principle that it works by is their resistance changes predictably with temperature, usually made from platinum wire. Some key features is they're highly accurate, stable, and have a linear response. Applications you'll find them in, you'll find RTDs in lab equipment, HVAC systems, and industrial ovens. Next up are thermocouples. Its working principle is that it uses two dissimilar metals that generate a voltage when heated. This is called the Seebeck effect. Some key features of the thermocouple is that they can handle a wide temperature range, they're rugged, and they respond fast. Applications that'll be found in is furnaces, engines, and other high temperature processes. Then we've got infrared sensors, also called non-contact sensors. Their working principle is they detect thermal radiation, basically IR waves coming off an object. Some key features: they don't need physical contact, so they're great for moving or hazardous objects. Its application is perfect for food processing, metalworking, and electrical inspections. Pressure sensors, their purpose is to measure the force exerted by gases or liquids in a system. Let's look at a few types. There's pressure gauges. These are mechanical. Its working principle is that it uses a burden tube or diaphragm that deforms under pressure, and that moves a needle. Its key feature is that it's simpler and it doesn't need power. Applications you'll find it in is used in tanks, pumps, and compressed air systems. Pressure transmitters, these are electronic, and its working principle is that it converts pressure into an electrical signal, like 4 to 20 milliamp or 0 to 10 volts. Key features with this: it's great for remote monitoring and other high accuracy applications. Found lots of times in process control and SCADA systems. Then you got pressure switches, right? Its working principle is these trigger an electric contact when pressure reaches a certain point. Features for this: it's common for alarms or safety cutoffs. You'll find its application, think boilers and hydraulic systems. Flow sensors, this is a really big popular one. These measure how fast liquid or gas moves through a pipe. Let's check out the different types. First off, you got magnetic flow meters, also known as mag meters. Its working principle: based on Faraday's law, which is voltage is induced when conductive fluid moves through a magnetic field. Its feature is there's no moving parts, but they only work with conductive fluids. Applications common in water treatment and chemical processing. You also have ultrasonic flow meters. Its working principle is it measures the time difference or the Doppler effect of ultrasonic waves. Some key features of ultrasonic: they're non-invasive and work with most liquids. You'll find it used in oil and gas and wastewater applications. Coriolis flow meters. These measure mass flow using vibration deflection. This is the Coriolis effect. Some features about the Coriolis meter: they're highly accurate and can also measure density. Applications perfect for food and beverage and pharmaceutical industries, as well as water and wastewater. Level sensors, its purpose is to detect how high liquids or solids are in a tank. Let's look at the main types. First, there's radar level sensors. They send out microwave pulses that reflect off the material surface. The time of flight is used to calculate distance. Features for this is they work in harsh environments and don't need to make contact. Application is great for chemical storage and bulk solids. Then there's the ultrasonic level sensors. They bounce sound waves off the surface, and if the time delay tells you then the level. Some key features of this is they're affordable and they're also non-contact application. Used a lot in water tanks and silos. Then you have analytical sensors, right? These measure chemical properties of liquids. Let's run through the most common types. There's pH sensors, and it measures hydrogen ion activity. That's a voltage difference between a reference electrode and a glass electrode. Key features with this, it's super important for chemical reactions. Applications used in water treatment and even breweries. You have conductivity sensors, and they measure how well a solution conducts electricity based on the ions in it. Some key features with this is it can detect purity or salinity. Application is going to be in desalination systems and pharmaceuticals. So let's summarize some key takeaways. Each sensor type has its own unique working principle, and each one is suited for specific industrial needs. The right choice depends on your required accuracy, the environment you're in, and the application itself. Industrial automation depends on these sensors. They make real-time monitoring and control possible. So let's recap what we covered. We broke down the most common sensor types used in industrial automation, from temperature and pressure to flow, level, and analytical sensors. We also looked at how each one works, what makes them unique, and where you'll find them in the real world, whether it's a chemical plant, a food production line, or a wastewater facility. Bottom line, sensors are the backbone of any automated system. They give us the eyes, the ears, and the touch we need to monitor and control everything around us. And now you understand how they work. For hundreds of thousands of other industrial automation products, go to our website at rspsupply.com, the internet's top source for industrial hardware.